Friends, welcome in the class of floating static route. Here I took three routers R1, R2 and R3. I am using subnet 10.1.12.0 between R1 and R2 and using subnet 10.1.23.0 between R2 and R3 and one loop back. So the primary routing protocol I am using OSPF. For enabling OSPF I have to go to the interface level IP OSPF 1 area 0. Same command I have to put on the loop back. Now I go to the R2. Same to the first interface, same in the other interface, R3 also. Right, so I have for a primary routing protocol I'm using OSPF. So now if you check the route, show IP route OSPF, you will receive some route within few seconds because it need to be synchronized first, so it will take some time. Two-way state, it will come up within few seconds. It will take some time, so we have to wait. It's synchronized with 1, but with 3 it's not yet synchronized. It's in the process. Yes, it's done now. It's done. So in R1, if you check the route for 3's loop back, show IP route for, you can see that the route comes from OSPF. So this is the primary route I can reach. So what I can do, I can use the static route as a floating route for this subnet. But what I have to do, I have to increase the AD value from the OSPF AD value. OSPF AD value is 1110. So I have typed it 1111. So still if you check, you will receive the routes from OSPF because the AD value of OSPF is less than the AD value of this route because I have increased the AD value. But if you delete the OSPF here, you still have a route for this by static routing. So this is the benefit of floating static route. If your primary route goes down, you have one alternative route, right? So this is about floating static route. Thanks. Welcome in the configuration class of static routing. Here we have three routers R1, R2, R3. We are using the subnet 10.1.12.0 between R1 and R2, and we are using subnet 10.1.23.0/24 between R2 and R3. And we have already created three loopbacks. One on router R1, which is 1.1.1.1, 2.2.2.2 on R2, and 3.3.3.3 on R2. So let's begin the configuration on R1 of static routing. So for that we have to go in configuration mode, type the command IP route 10.1.23.0.255. This is the subnet mask. And what is the next hop? The next hop is 10.1.12.2. Again we have to type the command for 2's loopback, which is 2.2.2.2, and the subnet mask is this, and for 3's loopback, which is 3.3.3.3. So this is the static routing configuration of router R1. So we can check by this command, show run section route, and we can paste it out for your knowledge. This is the R1 configuration. Now go to R2. We already have the information about the subnet 10.1.12.0 and 23.0. So we have to configure only two static route. One is for 1's loopback, which is this. Next hop is 10.1.12.1, and one is for 3's loopback, which is this. And the next hop is 10.1.23.3. This is all about R2 configuration. Because we already have the subnet information, so we have only configured the static route for the loopbacks of R1 and R3. Now same for R3, go to R3 and first of all configure the route for the subnet 10.1.12.0 because you don't have directly connectivity for this subnet, and the next stop is this, and then configure the static route for once loop back. Right, and one is for to loop back. Right, so this is the configuration of static routing under R3. You can check by this command, and I have just pasted here so that you can note it down in your copy and further you can do it by yourself. So for verification, go on R1 and type the command show IP route. Once you type this command, you will get to know that now you have a static route for router 2's loop back, router 3's loop back, and the subnet between router 2 and 3. And you can see here the AD value is 1 because the AD value of static routing is 1, and we don't have any metric used because we are configuring and we are using here only static routing. We are not using any dynamic routing protocol. So just try to ping. We have reachability, and here also we have reachability. What is the main concept of static routing is, once you go and try to ping the loopback of another router, just try to type show IP route this particular subnet. Then you got to know that the next hop 10.1.12.2, this should be reachable. If this network is not reachable, then the configuration which you did of static routing is not valid, right? So for verification, you need to just check like this, show IP route 1.1.1.1, and you need to find the next hop, and you should have reachability to that next hop anyhow. Otherwise, the command which you have run for that particular route is not valid, right? So through this way you can verify your static routing. So this is the configuration which we did, and I think this is enough for CCNA static routing configuration. Thanks. In this current class, I'm gonna configure RIP authentication on RIP version 2. So first of all, what I did, I have just configured the IP address on the interfaces, and I have assigned the IP address for loopback, which is 1.1.1.1 for router 1, and same for router 2. I have assigned IP address on the interface, and I just gave the IP address to the loopback interface, which is 2.2.2.2. Now on R1, I'll just go to configuration mode, and I'm just gonna enable RIP, which is version 2, no auto summary, and network I have to advertise, which is 10.1.12.0, and network 1.1.1.1. Same thing I need to do on R2. I have go to the configuration mode, router RIP version 2, no auto summary, network 10.1.12.2. We have to give the network, which is 10.1.12.0, and network 2.2.2.2. Now our RIP configuration has been done. For that, we have to go to R1 and type the command show IP route RIP. We are receiving the route from a RIP, and we can ping so that we can cross verify the connectivity through RIP, and we are reachable, right? Now for configuring the authentication in RIP, you have to first of all create a key chain, and for that you have to give the name. Let's suppose I am giving the name Cisco, okay, and which key? It's key 1, and the key string, let's suppose Cisco 123 is the key, right? Then after, you have to go to the interface, IP RIP authentication mode. Two type of authentication you can configure. One is clear text and one is MD5. I am using MD5 here. IP RIP authentication keychain Cisco, right? So once you have configured this authentication, you will not receive any route through RIP. It will take 30 more seconds to go. Let me clear IP route. See why you are not receiving the route, because you have configured the authentication on this interface, but you have not giving the same password here. So for making the neighborship again, you have to assign the same password. For that you have to go to keychain, let's suppose Cisco key 1. What is the key string? It's Cisco 123. This should be same. The name you can take it different, but the key string, this should be same on both the device. Then again you have to go to the interface, IP RIP authentication mode, which MD5, IP RIP authentication keychain is Cisco. So once you have configured this, the same key on both the interfaces, we have just cleared the route, so that it will again make the neighborship. Otherwise it will say take 30 seconds. Now see, now you can see you are receiving the route after configuring the authentication, right? So when you type the command show IP protocol, you can got to know that you have running this authentication here. See, you are running a keychain, the name is Cisco. So by the help of this authentication you can confirm that both the routers are legitimate and they already using a keychain where a password is already assigned, so that illegitimate router is not able to make the neighborship with a legitimate router. Okay, so I think this is enough in RIP authentication. Thanks. Hello friends, welcome in the class of basic STP. Here you can see we have 2 laptops and we have 3 different switches I took. Okay, so what is the basically what I'm trying to do, I'll try to show you the by default configuration of STP, and then we will change the root bridge location. Okay, so first of all we have to go to the loopback 0 and assign an IP address, let's suppose, which is standard 1.1.1 and the subnet mask is default. We have to go to the laptop 1 and we have to align the IP address, let's suppose, which is standard 1.1.2, right? Now I'm trying to ping to my another laptop which is standard 1.1.1. I can. So here if you open all the switches, let's suppose this is switch 0, and you try to check show spanning tree VLAN 1, because by default all the ports are in VLAN 1. You can see that okay, this is the root bridge information and this is my information, right? So I am not root because these both information are not same. So if I go to the switch 1 and I'm trying to check here show spanning tree VLAN 1, you can check that here also the information is not same, or maybe it's same. We need to check. See, the information is same. That means switch 1 is by default the root bridge, right? Because see, you can see here it's showing that this bridge is the root. So that means if this bridge is the root, all the ports are in designated mode, right? These 2 ports are in designated mode. That means these ports should be the root port, right? Definitely. So here if you go to the switch 0 and you check the port number FA0/1, which is this port, this is the root port, right? And if you go to the switch 2 and try to check show spanning tree VLAN 1, see, this is the root port, which is FA0/1. Now one port is in the designated port and one port is the block port. Switch 0 port number, this one is in blocking state, right? So this is the by default configuration. Now let's suppose I want to make this switch 0 as a root bridge. So I have to type one command, which is spanning tree VLAN 1 root primary. This is a micro command. Once you type this command show spanning tree VLAN 1, you can check here. Now this bridge is the root. Once this bridge will be the root, see, the root bridge information, the root bridge MAC address and this particular switch MAC address will be the same, right? So now all the ports are in designated state. They are changing the states. It will take some time. See, now see, all the ports are in designated state. That means these ports are root ports and this is the blocking state now. So this is the by default behavior of STP. by the help of basic command, which is spanning tree, VLAN, whatever VLAN you want to run, root primary macro command, you can make a switch as a root bridge. So this is the basic information about the STP. Thanks. In this current topology, we have three routers named router 1, router 2 and router 3. Router 1 basic interface configuration is this, where the IP address of interface fast Ethernet 0/0 is 10.1.12.1 and the IP address of loopback is 1.1.1.1. The same thing in R2. Once we check the IP address, it's 10.1.12.2, 23.2 and one loopback which is 2.2.2.2. On router 3 we can check with the command show IP interface brief. It's 10.1.23.3 and the loopback address is 3.3.3.3. Now I'm gonna configure RIP version 2. For that we have to go to global configuration and mode and type router RIP. Press enter. Then we have to type version 2 and one more command we have to type, it's no auto summary. After that we have to provide the networks which we want to advertise in RIP, which is 10.1.12.0 and the loopback address. This is done. This is the configuration on R1 of RIP, and now the R1 is enabled. Go to R2 under the RIP process, type version 2, no auto summary, and you have to assign the network which is 12.0, one more network and .1.23.0 network, which is the loopback. And for router 3 we do the same thing, which is router RIP version 2, no auto summary, network 10.1.23.0, network 3.3.3.3. Now what we can check, we have already seen the topology. Here is R1, R2, R3 which are connected through fast Ethernet interface. Now if we need to check the output on R1, the command is show IP route RIP. Once you check this command, you can see that you get the the loopback address of router R2, the loopback address of router R3 and the subnet between R2 and R3, which is 10.1.23.0. This is the AD value of RIP and this is the metric, which is 1 for 2's loopback and 2's for 3 loopback. If you want to check what protocol we are running on this device, the command is show IP protocols. Here in this command you can see that we are running RIP, right? These are the different timers of RIP which we will discuss further in CCNP RIP, and these are the interface and the loopback which are part of RIP and sending and receiving RIP version 2 messages. And this is the AD value of RIP, which is 120, and the uptime is last 11 seconds, right? And these are the network which we have advertised. And there are one more command which is maximum path 4. What is the meaning of this command? This command shows that by default RIP is doing load balancing up to 4 equal cost path. So now if you check on the output show IP route RIP, we have 2's loopback, 3's loopback, right? On R2 we can run the same command, which is show IP route RIP, right, which is 1 and 3's loopback. And on R3 again it's show IP route RIP, which is 1, 2's and this subnet. Now if we need to check the connectivity, type ping command. We can reach, type the 1's loopback. We can reach, type the 3's loopback, right? So here if you want to check what the configuration you have done, type the command show run section router RIP, and you can copy this, and we can do one thing, we can paste it out on under R1 scenario. This is our R1 configuration RIP. On R2 we can run the same command, which is section router RIP. This is the command which we have run on R2 under our configuration. And one more command, one more thing, which is show run section router RIP, which is the R3 configuration, and it's done. Okay, now these are the configuration which we did yet. This is the basic CCNA example of RIP, how you can configure RIP. For further topics, we will discuss about the RIP authentication and the how we can change the metric of RIP. In the meanwhile, you can check on Wireshark. If you use Wireshark, you can check. Let me remove this first. Now, if you check if you're capturing the packet, you can see that in RIP version 2 we are using the multicast address of RIP, which is 224.0.0.9. so I'm just trying to show you that if you capture a packet and if you will start the Wireshark, you can check that you are using RIP multicast address. From here also you can check what's the command, debug IP RIP packets or debug IP RIP events. Here also debug IP RIP events. So now you can see from this output you can check that, let me debug all, that we are using multicast address 224.0.0.9 for RIP, right? And our Wireshark result will also show the same thing. It will take one more moment to come up. Yeah, see, if you see here, it shows, okay, a letter, yes. Now here you can see that RIP is using UDP protocol number 520, right? Here we can see the source port is 520 and destination port is 520, and this is the routing information protocol RIP. And if you go into the network layer header, here you can see that the destination address is 224.0.0.9, which shows it's using the multicast address, right? So on this way you can check that here you can see that it's using UDP port number 17. That means in transport layer it's using UDP. So by this way you can check the the header of a protocol and you can identify some information. I think this is enough for the basic CCNA RIP class, and we will discuss other topics of RIP in CCNP class. Thank you. Hello friends, welcome in the class of basic STP. Here you can see we have 2 laptops and we have 3 different switches I took. Okay, so what is the basically what I'm trying to do, I'll try to show you the by default configuration of STP, and then we will change the root bridge location. Okay, so first of all we have to go to the loopback 0 and assign an IP address, let's suppose, which is 10.1.1.1 and the subnet mask is default. We have to go to the laptop 1 and we have to align the IP address, let's suppose, which is 10.1.1.2, right? Now I'm trying to ping to my another laptop which is 10.1.1.1. I can. So here if you open all the switches, let's suppose this is switch 0, and you try to check show spanning tree VLAN 1, because by default all the ports are in VLAN 1. You can see that okay, this is the root bridge information and this is my information, right? So I am not root because these both information are not same. So if I go to the switch 1 and I'm trying to check here show spanning tree VLAN 1, you can check that here also the information is not same, or maybe it's same. We need to check. See, the information is same. That means switch 1 is by default the root bridge, right? Because see, you can see here it's showing that this bridge is the root. So that means if this bridge is the root, all the ports are in designated mode, right? These 2 ports are in designated mode. That means these ports should be the root port, right? Definitely. So here if you go to the switch 0 and you check the port number FA0/1, which is this port, this is the root port, right? And if you go to the switch 2 and try to check show spanning tree VLAN 1, see, this is the root port, which is FA0/1. Now one port is in the designated port and one port is the block port. Switch 0 port number, this one is in blocking state, right? So this is the by default configuration. Now let's suppose I want to make this switch 0 as a root bridge. So I have to type one command, which is spanning tree VLAN 1 root primary. This is a micro command. Once you type this command, show spanning tree VLAN 1, you can check here. Now this bridge is the root. Once this bridge will be the root, see, the root bridge information, the root bridge MAC address and this particular switch MAC address will be the same, right? So now all the ports are in designated state. They are changing the states. It will take some time. It will see. Now see, all the ports are in designated state. That means these ports are root ports and this is the blocking state now. So this is the by default behavior of STP. And by the help of basic command, which is spanning tree VLAN, whatever VLAN you want to, one root primary macro command, you can make a switch as a root bridge. So this is the basic information about the STP. Thanks. Hello friends, welcome in the class of basic STP. Here you can see we have 2 laptops and we have 3 different switches I took. Okay, so what is the basically what I'm trying to do, I'll try to show you the by default configuration of STP and then we will change the root bridge location. Okay, so first of all we have to go to the loopback 0 and assign an IP address, let's suppose, which is 10.1.1.1 and the subnet mask is default. We have to go to the laptop 1 and we have to align the IP address, let's suppose, which is 10.1.1.2, right? Now I'm trying to ping to my another laptop which is 10.1.1.1. I can. So here if you open all the switches, let's suppose this is switch 0 and you try to check show spanning tree VLAN 1, because by default all the ports are in VLAN 1, you can see that okay, this is the root bridge information and this is my information, right? So I am not root because these both information are not same. So if I go to the switch 1 and I'm trying to check here show spanning tree VLAN 1, you can check that here also the information is not same, or maybe it's same. We need to check. See, the information is same. That means switch 1 is by default the root bridge, right? Because see, you can see here it's showing that this bridge is the root. So that means if this bridge is the root, all the ports are in designated mode, right? These 2 ports are in designated mode. That means these ports should be the root port, right? Definitely. So here if you go to the switch 0 and you check the port number FA0/1, which is this port, this is the root port, right? And if you go to the switch 2 and try to check show spanning tree VLAN 1, see, this is the root port, which is FA0/1. Now one port is in the designated port and one port is the block port. Switch 0 port number, this one is in blocking state, right? So this is the by default configuration. Now let's suppose I want to make this switch 0 as a root bridge. So I have to type one command, which is spanning tree VLAN 1 root primary. This is a micro command. Once you type this command, show spanning tree VLAN 1, you can check here. Now this bridge is the root. Once this bridge will be the root, see, the root bridge information, the root bridge MAC address and this particular switch MAC address will be the same, right? So now all the ports are in designated state. They are changing their states. It will take some time. It will see. Now see, all the ports are in designated state. That means these ports are root ports and this is the blocking state now. So this is the by default behavior of STP, and by the help of basic command, which is spanning tree, VLAN, whatever VLAN you want to run, root primary, macro command, you can make a switch as a root bridge. So this is the basic information about the STP. Thanks. Hello friends, welcome again. Here in this topology I'll take two routers. Here one router is working as a DHCP server and one router is working as a DHCP client. So my target is, my today's goal is to make R1 as a DHCP server and R2 get the IP address from R1 dynamically, right? So for that we have to go to R1 and let's suppose go to interface and shut that and provide an IP address. Let's suppose 10.1.1.1 and it's 255.255.255.0, right? Then we have to type the command here, IP DHCP pool. Let's suppose I have created a pool name which is Cisco. Let's suppose new tech, new tech, right? Then we have to provide the network. You can see, you can just question mark and find out what are the commands, network number and mask. So you can assign the network command which is 10.1.1.0 and mask. Okay, then you get /24. Not taking like this, then you can 255.255, sorry. Done. Then IP default gateway, default router is, let's suppose this router. IP DHCP excluded address. I want to exclude address. Let's suppose I'm excluding the interface IP address of R1 because I have already assigned this IP address on an R1 interface. So I don't want this interface to be assigned to any client, right? So this is the configuration of DHCP, right? I've created a pool, I have assigned the network and I have assigned the default router. So if you go to R1 and go to the interface and type the command no shut IP address DHCP. So once you type this command on R2, this means R2 will get the IP address from R1. Let's see. Now see, I get the IP address from R1 which is 10.1.1.1 and this is getting by DHCP. Here if you go on R1 and type the command show IP interface brief, you can see here it's manual. So this is the difference. So you can dynamically get the IP address by this. Here you can no need to configure a lot of commands. It's only 3 commands, which is IP DHCP pool. You have to create a pool. Then after you have to assign the network which you want to provide, and then what is the default router, right? Thanks for listening. Hello friends, welcome again in the class of basic CDP and why we use CDP. CDP is used to identify the information about the neighbor device through which we are connected, right? So in this topology I took two routers, one is router 1 and one is router 2, and I'm using the subnet 10.1.12.0 between them. Okay, so you can see the basic configuration here. Show IP interface brief on router 1. I have just assigned the IP address on an interface fast Ethernet 0/0, and this is the IP address. On R2 also the same thing, we have the connectivity. Okay, now the work of CDP. Let's suppose you only have access on R1 and you want to know about the information neighbor device. So what you can do, first of all, you can run the command show CDP neighbor. By the help of this command you can got to know that your neighbor device is R2, which is connected to your local interface 0/0. The total hold down timer is 145 seconds, and this is a router because this R means router. Platform is 3640 and the interface of neighbor device is fast Ethernet 0/0, right? If you want more information about the neighbor device, then in that case you have to type the command show CDP entry star. By the help of this command, you will get to know about the IP address of the device, the hold down time of the device, the total number of ports, the version of the device, software release, and the duplex mode. All this information you can get to know by this. Okay. Then show CDP interfaces. This says on which interfaces our CDP is enabled. Here it shows that on fast Ethernet 0/0 it's up, right? And the CDP packet hello timer is 60 seconds and the hold down timer is by default 180 seconds, right? And one more command you can run. You can see here, show CDP traffic. So by the help of this command, show CDP traffic, you can get to know what is the advertisement, how many advertisement you receive, total output packet is 7, total input packet is 7, right? So these are the information you can get to know by CDP. This is basically used to identify the neighbor device and the information about that particular device, right? If you want to disable CDP on an interface, then you go to the interface, no CDP enable. So once you type this command on an interface, it will take 60 to 180 seconds to, let's suppose go into the interface of R2. Right? Then show CDP enabled. CDP is not enabled. Right? Here also. Where we can run this command? We run this command, let's suppose our router is connected to a public domain device where we don't want to share our information. In that case, you can go to the interface level and disable the CDP by this command, right? This is all about basic CDP configuration in CCNA. Thanks.